should have your shortcut notes out as well. Today, what we're going to be doing is down at the bottom. We've been working with congruent triangles and finding all of the congruent parts of a triangle. Now we're working backwards. They're going to give us the parts of the triangle, and we need to prove that the triangles are congruent. They're going to give us the parts. Like if I look at this one, what have they given me on this triangle right here? Because we're going to start with the parts. When I see 3 sides of one triangle are congruent to 3 sides of another triangle, what theorem am I going to use to say that they're congruent? I'm going to use the SSS, side, side, side. When I see 3 sides of a triangle are congruent to 3 sides of another triangle, that means that they're going to be congruent by SSS. Exactly. When I look at these 2 sets of triangles, I see that there are 2 sides and an angle. And it's very important where that angle is. I have 2 sides, and it's called the included angle. It's between the 2 sides. You have to read it in order, just like when we were doing triangles and we had to make sure that our triangles were in order. When we were labeling these, we would say that, let's label this triangle right here. I want to label this triangle as what? I always like to start where the one side is. So I'm going to say A, B, C. Triangle ABC is congruent to, I did the one side, the 2 side, and then so we go P, Q, R. That means that all my lettering better match up to the left. We can tell by looking at this congruency statement that sides are congruent and that angles are congruent. According to this, it should say that angle A is congruent to angle P. Is that true if I look at the picture? A and P. Now, if I look at B and what is going to be congruent? B and Q. So I look and see B and Q. So order matters. We've seen that, haven't we? Every single time that we're doing this, we have to make sure we're going in order. So according to this, let's see. AC, side, AC is going to be congruent to what side? Side AC is going to be congruent to what side? Exactly. I'm going to look at my picture now. AC and PR have the same markings. So we know that order matters. Well, that's going to be still true when we're looking at all the parts and we have to name what it is. It's not side, side, side. It's 2 sides and an angle. But how do I say that? You have to go in order. Ready? It's always going to be side. What comes next? Angle. And then what comes? Side. This is side to the angle to the side. If it's going to be side, angle, side, look at the angle has to be in between the 2 sides. I can't start here and go in the reverse direction. Side, well, there's no angle when I go in this direction. There's no angle. It has to go in that order. Okay, there's 4 theorems that we're using. We could also use, on this one, look at the side now is in between the 2 angles. Angle to a side to the very next angle. Angle, side, angle. Angle, side, angle. I could go this way. Angle, side, angle. And the last one is when you have 2 angles and then a side. So you would go angle to the very next angle. Is there anything there? I can't be going that way then. Angle to the very next angle. Oh, there it is. Angle, angle, and then side. So order matters in how you're going around the triangle when you're trying to find your theorems. If I'm looking for angle, angle, side, and I start at this angle and I go up here, no, there's nothing there. I got to make sure I'm going in order. Let's practice these. Keep your theorems out so you can see them. Let's practice on the first one. Number 1, I only see 2 markings. But we've used it before, the reflexive property, when you have something that both share. In this picture, what do both of those triangles share? That would be the same in both triangles. Right here, this side. Is this side in the first triangle? Is this side in the second triangle? It's the same size, right? So it's congruent to itself. There, now I have 3 markings and I need to go in a row. Blank, blank, blank. What is it going to be? It's definitely not side, side, side. So I go from an angle to the very next side to the very next angle. I agree. angle, side, angle. Try number 2. First of all, how many sides does it have? Well, how many sides for the markings? And how many angles? So I'm looking for something that has 2 sides and an angle. So what are my choices for something that has 2 sides and an angle? Do I have multiple choices or only one choice? You're looking for something that has 2 sides and an angle. 2 sides are marked and an angle is marked. So this one has 2 sides and an angle. Now I'm just going to check to make sure. Ready? Side to the angle to the side. Side, angle, side. I agree. Try number 3. I only see 2 markings. Remember, we're always looking for free information. I need to mark something. Annabelle, is it going to be a side or an angle that's being shared by these 2 triangles? This is exactly right here. They both share this side. It's in both the triangles. So this is my 3rd marking then. So according to this, what's it going to be? How do I know that the first triangle is congruent to? Exactly, side, side, side. So you're looking for free information. That's not the only kind of free information we've had before. Looking at number 4, what is some free information that I know this is going to be congruent to that? What's that rule called? I only have 2 markings, and they don't have a side they're sharing this time, but they do have something that's congruent. Blank angles are congruent. That's your X right there. Vertical angles are congruent. So that means I could say that this vertical angle is congruent to this vertical angle. I have to put a line on the half circle because I've already got something in there that has a half circle. So I don't want them to look the same. So now I'm looking for a theorem that has 2 angles and a side. How many choices do I have for 2 angles and a side? I have 2 choices this time, so I got to make sure I'm picking the right one. Both of these have 2 angles and a side. I need to figure out if it's going angle, angle, side, or is the side in between the 2 angles, angle, side, angle. Check. I agree, but check the theorem. We go in a different direction. I agree what you said. What should it be? Very good. Go the other way. Angle, angle, side. Okay, finish the next 4. Looking at number 5. I have enough markings. I see 3 in each one. Penny, what do you think about number 5? What would say these 2 triangles are congruent? Very good. Angle to the very next angle and the side. That means that those triangles are congruent. We're trying to prove if these triangles are congruent. So angle, angle, side, 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 angle, side, angle. Those are all ways to tell us that these triangles are congruent. How about number 6, Annabelle? So there weren't enough markings, so I'm sure she used this property here to make another marking. You need to have 3 markings in every triangle, and then it's the side is in between the 2 angles. So that would be angle, side, angle. The side is in between the 2 angles, just like the theorem says, angle, side, angle. The side is squished in between the 2 angles. Okay, Brandon, how about number 7? Angle, side, angle. So that tells me that you have 2 angles in a triangle that are congruent. How did you get another angle? I see 1 angle and 1 side. I do need another marking. Did you mark one of these other angles as being congruent to each other? Over here? So there's nothing there, though, that tells us that those are congruent. Is there some way that we could put a marking in here that we know for sure it's in both triangles that it's congruent? That's right. Right here. This side right here is used in both the triangles. This is where you want to mark. Okay? And then try it again. Now that you see that that's going to be your markings, which theorem is going to say that those 2 triangles are congruent? Very good. Side, angle, side. The angle is in between the 2 sides. Okay, Boston. Last one's yours. How do I know these 2 triangles are going to be congruent? Very good. They gave me 3 sides. 3 sides congruent to 3 other sides. So that's side, side, side. What they've done here is they've told you the postulate or the theorem that they want you to use. Side, angle, side. And right now, all I have is a side and an angle. Where would I put the third side? I have side angle. Where would I mark to get side, angle, side? Which side am I going to mark right now? Give me the 2 letters that name that side. So PR. And then it would be, where is it? Side, angle, side. Side, angle, side. The angle is in between the 2. So you would say that PR is congruent. I need different markings. Thank you. So I would say PR is congruent to, well, with PR, nothing to 1. Nothing to 1. Remember, order matters. I started with no angle to an angle. I need to make sure when I'm looking at the start, when I name it, it would be V to U. All right. Number 2, we're looking for angle, angle, side. Let's start with the side first. What side? We're going to mark this side. So for that one, you would just say that AC is congruent to AC. It's congruent to itself. It's used in both the triangles. But I do need to find the other angle that goes with it. It says angle to side. Which angle would I have to mark so that this theorem works? Angle to angle and then the side. I wonder if it's going to be angle B or C that would work. Needs to be angle to the very next angle and then the side. Which one? If I put it here, what would this theorem say? If I put it there, what would it say? It'd say angle, side angle. So it can't be that one. It has to go over here so that it goes angle to the very next angle and then the side. So we would say angle B is congruent to angle D. Now I have those 2 triangles being angle, angle, side. Okay, try the next couple. I got to go get your paper. It says angle T equals angle K. That's what you had for markings in your triangle, but you didn't write anything about angles on that one. This is what it says. Angle T is congruent to angle K. That's how you notate angles. Not sides.